class. It is ground state of helium. Okay, so here we are going to study an example which is ground state of helium. We are using the variational principle. Okay, we know hydrogen atom has one electron and one proton, isn't it? So we know the Hamiltonian and its solution, energy eigenvalue, all those things we know for the hydrogen atom. Now let us see what happens, what is the ground state energy of helium. So helium atom consists of 2 electrons and 2 protons. So here we don't consider 2 neutrons inside the nucleus because it is not giving any potential energy because it is not having any charge. So neutrons are not relevant here. Now let us take the Hamiltonian of the system. Here 2 electrons and 2 proton system. So let us see what is the Hamiltonian of this system. So first let us draw the diagram as shown here. 2 protons inside the nucleus, so they are drawn as a point 2e plus 2e protons, and see here the 2 electrons which are at distance r1 and r2 respectively, isn't it? So the 2 electrons, they are moving around the nucleus, so they are at r1 and r2 distance respectively. We don't know what is r1 and r2. Let it be like that, and the distance between these 2 electrons will be r1 minus r2 modulus, isn't it? So you should draw this diagram, and then now let us see what will be the Hamiltonian. Using this diagram we can draw the potential energy of this system. So first see the kinetic energy. The moving particles or moving parts here are electrons only. Nucleus is stationary. So those 2 electrons, first and second electron, are having kinetic energy P1 square by 2m by and P2 square by 2m. So first let us write the kinetic energy. H is equal to minus h cut square del 1 square by 2m plus minus h cut square del 2 square by 2m. They are the kinetic energy of these 2 electrons. We took the sum of it, and then let us take the potential energy. Here 1 by 4 pi epsilon 0 q1 q2 by r will be the potential energy because they are Coulomb. It is Coulomb potential because they are charged particles. So we have here how many particles? Here we are considering particles as 3 entities. First is the protons. They are together. We call it as we know the charge of them are plus 2e. Plus 2e is the proton which is in the nucleus. So that is the first entity. The second entity is the first electron which is at r1 distance away from the nucleus, and the third entity is the second electron which is at r2 distance away from the nucleus. So we need to write the potential energy of these 3 entities. How they can be written, let us see that. First we consider the potential energy of potential energy between the protons plus 2e and the first electron which is at distance r1 away. So that will be 1 by 4 pi epsilon 0 2e into minus e, that is 2e square minus 2e square, isn't it? So minus 2e square divided by r1. That is what written here in the first term. It is minus 2e square by 4 pi epsilon 0 into r1. Understood? The second one will be the potential energy between the protons plus 2e and the second electron which is at distance r2 away. So that will be 1 by 4 pi epsilon 0 2e square divided by r2. That is what second term represents. 2e square by 4 pi epsilon 0 into r2 minus. So these two are plus 2e into minus e, and it will be minus terms, minus 2e square, isn't it? Now we take the third term, which is the potential energy between two electrons. See that the two electrons are at distance r1 minus r2 modulus, isn't it? So that will be minus into minus, that will be plus E square, plus E square by r1 minus r2. So plus E square by 4 pi epsilon 0 r1 minus r2 modulus will be the value of potential energy between two electrons. Now this is the Hamiltonian of the system, equation 1. Okay. Now we know experimentally the ground state energy of helium is already found out by very accurate method. It is very accurately found out to be equal to minus 78.975 electron volt. That is the experimentally determined value. Now this value we have to derive theoretically. So in order to derive theoretically, we need to find the expectation value of H there. We know equation 1, we have written the value of Hamiltonian. We just need to take the expectation value of this equation 1. For finding it, let us just take the repulsive potential between the two electrons, which is the last term in the equation 1. Repulsive potential between two electrons, that is, we call it as VEE. Repulsive potential, two electrons, that is why EE is written. So VEE is equal to E square by plus E square by 4 pi epsilon 0 into R1 minus R2 modulus. So that is the value of a repulsive potential between two electrons, and equation number 2. Understood? Now let us say that if we ignore VEE, if we don't take VEE, we just take the first 3 terms. Then how can you compare? Can you compare it with the hydrogen system? So that is what we are saying. If we ignore VEE, H Hamiltonian, which is H, splits into two independent hydrogen Hamiltonian. Only difference is that the nuclear charge is 2 there. In hydrogen it is 1 only, but in this system it is having 2 protons. So nuclear charge is 2E plus 2E. That is the only difference. Instead of E, the nuclear charge is plus 2E. So you can say that it is only 2 hydrogen Hamiltonian, 2 independent hydrogen Hamiltonian, except the repulsive potential VE. If you don't consider VE, it is 2 hydrogen Hamiltonian with a nuclear charge 2E. So the exact solution is the product of hydrogen wave functions, 2 hydrogen wave functions. So the wave function, you can write it as psi 0 r1 r2 as psi 0 r1 psi 0 r2, psi 0 r1 into psi 0 r2. So 2 hydrogen wave function, hydrogenic wave function we take, and we take the product of it, and that product is considered here as the solution. We have considered this wave function as the trial wave function in this helium atom system. Okay, so we didn't consider the repulsive potential between 2 electrons there. We know already this wave function. We have derived it in identical particle section. I have taught you already identical particles in the last module. This not in this module, but in the last module we have studied identical particles. In that section you just go and check. We have directly written, we have taken that equation here. The wave function of the helium atom, it is 8 by pi a cube into e raised to minus 2 r1 r2 by a. If you want to see, I will just show you now, which is there in the identical particle section. Let me just see. This variation principle. This is identical particle system. Okay, so now let us go to the wave function. See here it is written, the energy it is written 8 into 8 E1, it is written 8 it is 8 times 13.6 electron volt. Already energy is written. A wave function is, it should be written here. Let us see. Okay, it's not written, but when you go and check in the textbook, it might be there. Or you just remember this equation. Anyway, the energy is written. It's written here. This is 2 identical particles of mass in an infinite square well. Helium, it's only here. See here, helium Hamiltonian is written. It is the product of two hydrogen atom wave function. That's what shown here in equation 3. That you should understand. Okay, and the wave function, it's not written here, but you should remember that it is here as I said. I will show you. As I said, it is 8 by pi a cube into e raised to the product of two wave function, two hydrogenic wave function, which is 8 by pi a cube into e raised to minus 2 r1 plus r2 by a. And the energy is 8 into E1, which is equal to minus 109 electron volt. This is what we get from the wave from this equation. This is what we get if you consider the wave function of helium as two hydrogenic wave function, the product of two hydrogenic wave function. But you see here the real experimental value of Eg is minus 78.97, which is very, very far away from this minus 109 electron volt. So we need to do something else. It is very different from 79 electron volt, which is experimentally determined value. Now let us we apply variational principle using psi 0 r1 as the trial wave function. So here we take the wave function of two hydrogenic wave functions product as the trial wave function, and we include this repulsive potential also, because if you don't include the repulsive potential VE, we don't get the correct energy, which is, we get the value which is 8E1. It is equal to minus 109 electron volt. That is very far away from the experimentally determined value. So we need to really consider the repulsive potential also. So using this trial wave function, let us find the expectation value of H. So writing the equation using the trial wave function, H psi 0 is equal to 8E1. We know it is already found out for the for the other Hamiltonian terms except the repulsive potential. So let us just write 8E1 plus VE represents the total energy of the system, of the helium system. So 8E1 plus VE into psi 0. Okay, that is eigenvalue equation. H psi 0 is equal to 8E1 plus VE into psi 0. 8E1 is the solution which we got for the system without considering the repulsive potential, the 2 electron repulsive potential. Okay, that is equation number 4. Now let us find the solution. So first we take the expectation value of VE. We already found out the other term 8E1. We know already, that is the expectation value of the remaining part of the H except VE. So let us now take the part with VE only. So VE expectation is equal to, we know VE is plus E squared by 4 pi epsilon 0 R1 minus R2. So E squared by 4 pi epsilon 0, we can take it out, and writing the wave function psi 0 as 8 by pi a cube into e raised to minus 2 r1 plus r2 by a. So psi star psi will be e raised to minus 4 8 by pi a cube 2 times, it will be square. So 8 by pi a cube square, you can take it out. Integral of e raised to minus 4 into r1 plus r2 by a divided by r1 minus r2 into d cube r1 d cube r2. Understood that equation? So that is psi star v, psi v e psi, inner product. So psi star psi into v, that is all only written there. Okay, equation 5. Taking now integral with respect to r2 first, keeping r1 fixed. So in this integration we have d cube r1 and d cube r2. So first let us take the integral with respect to r2, keeping the other one, keep r1 fixed. We know by cosine law r1 minus r2 modulus is root of r1 squared plus r2 squared minus 2 r1 r2 cos theta, cos theta 2, where theta 2 is the angle between r1 and r2. As you can see here in this picture, the angle between, in this picture, angle between r1 and r2 is theta 2. Okay, so equation number 6. Now let us find the integral. See here in the last page, the constants are outside. Integral of exponential minus 4 r1 plus 4 into r1 plus r2 by a, that we need to find out, divided by r1 minus r2 modulus. So only took the integration there, integral part there. So integral of minus 4, r1 is fixed, so we don't take it. So 4 r2 only take, we have taken. So e raised to minus 4 r2 by a d cube r2 by r1 minus r2. Take that as I2. Here we took it as I2. So integration, we have substituted for r1 minus r2 modulus there, and d cube r2 is substituted as r2 square sin square theta 2 theta 2 dr2 d phi 2. Okay, so integral 0 to 2 pi d phi 2, the third term, d phi 2 will be 2 pi, equation 8. And now let us substitute, take the integration of the theta 2 term. So only take that part. I have taken 0 to pi. Integration theta 2 part will be 0 to pi only. So 0 to pi sin theta 2. All the other terms I don't take. Only I have taken the terms with theta 2. So sin theta 2 divided by root of r1 square plus r2 square minus 2 r1 r2 cos theta 2 into d theta 2. So now let us do that integration, only that part. Okay, so substituting x is equal to cos theta 2, dx will be minus sin theta 2 d theta 2. Okay, I have not written d theta 2 there. So dx, sin theta 2 d theta 2 will be minus dx. Okay, and root of r1 squared plus r2 squared minus 2 r1 into r2 into x. Now taken the integral, it will be minus 2 into root of r1 squared plus r2 squared minus 2 r1 r2x divided by minus 2 r1 r2. With the limit, the limit 0 to pi, theta 2 term limit will go to 0 to pi. When theta 2 is 0, x will be cos 0 1. So x will be, lower limit will be 1. And when theta 2 is minus 1, sorry, pi, cos pi is minus 1. So x becomes minus 1. So after putting the integration limit, you will get 1 by r1 r2 into root of r1 square plus r2 square plus 2 r1 r2 minus r1 root of r1 square plus r2 square minus 2 r1 r2. So substituting the values, and here we have taken here root 1 by r1 r2 into r1 root of r1 plus r2 whole square. So r1 square plus r2 square plus 2 r1 r2 is r1 plus r2 whole square minus root of r1 minus r2 whole square. So root of that is r1 plus r2. So root of the other term is r1 minus r2. So taken that, and R1 plus R2 minus R2 is when R1 is greater than R2, it will be the answer will be 2 by R1, and if R1 is less than R2, if R1 is greater than R2, it is 2 by R1, and if R1 is less than R2, it is 2 by R2. You can see that when you put the value. Okay, so remember this equation, it is now it has become two equations, isn't it? So that integration part becomes 2 by R1 or 2 by R2 depending on the value of R1 and R2. Okay, so equation 7 now is equal to I2. Integration of d phi 2 is 2 pi, isn't it? So 2 pi I have already written, and then this integral 0 to pi term, the theta 2 integral, it is 2 by R1. So 2 pi into 2 by R1, it will be 4 pi by R1. For the first case, R2 which R1 which is greater than R2, first case. So that is what written it, the first term in the bracket, 1 by R1. Now the integral remains only for R1 integral dr2 only it remains. Integration is only for dr2. Theta 2 integral, d theta 2 integral already we have done, and d phi 2 integral we have already done. So 4 pi by R1 we have taken already outside. Now we need only the term with the R2. So integral 0 to R1 e raised to minus 4 R2 by a into R2 square divided by dr2. R2 square into dr2. Okay, and that term comes when R2 is less than R1, and the other term it comes from the integration limit goes to because R1 is less than R2, isn't it? So R2 goes from R1 to infinity there. So R1 to infinity integral e raised to minus 4 R2 by a into R2 dr2. Why R2 square it is not coming? Because the integration term, it is the equation 9c, if R1 is less than R2, the integral 0 to pi theta 2 term, it is 2 by R2. So 2 by R2 into R2 square, it will be, R2 will get cancelled, only one R2 will remain. So that is why 1 by R1, instead of 1 by R1 in the first term, we have here 2 by R1 ആയിരുന്നു ഫസ്റ്റ് ടേമിൽ ഉണ്ടായിരുന്നത്. അതിലെ 2 എടുത്ത് പുറത്തേക്ക് പോയാണ് 4 പൈ ആയത്. 2 പൈ ഇൻറ്റു 2 ഇത് വിൽ ബി 4 പൈ. ഇവിടെ വരുമ്പോൾ 2 by R2 ആണ് അവിടെ വരുന്നത് അല്ലേ. അപ്പോൾ 2 പോയി 4 പൈയുടെ കൂടെ പോയി. പിന്നെ ഉള്ളത് 1 by R2 ആണ്. 1 by R2 R2 സ്ക്വയർ, മുകളിലെ R2 സ്ക്വയറുമായിട്ട് ക്യാൻസലായിപ്പോയി, ഒരു R2 മാത്രം റിമെയിൻ ചെയ്യും. മനസ്സിലായോ? സോ ദ ഇൻ്റഗ്രൽ becomes R2 into dr2 there. Understood? Now doing this integration, you will get the answer will be, you have to remember this is identity, ഒരു ഐഡൻറ്റിറ്റി ആണിത്. R2 into e raised to x into e raised to x എന്ന് പറയുന്ന ax എന്ന് പറയുന്നതും x square into e raised to ax എന്ന് പറയുന്ന രണ്ട് ഇൻ്റഗ്രേഷനാണ്. അത് നിങ്ങളൊന്ന് ഓർത്തിരുന്നാൽ മതി. ആ ഇക്വേഷൻ്റെ ആൻസർ ഇറ്റ് വിൽ ബി ലൈക്ക് ദിസ്, പൈ എ ക്യൂബ് ഡിവൈഡ് ബൈ 8r1 ഇൻറ്റു 1 ഈ ടേം നിങ്ങൾ ഓർത്തിരിക്കേണ്ട. ഇക്വേഷൻ 10 നിങ്ങൾ ഓർത്തിരിക്കേണ്ട. ലാസ്റ്റ് ആൻസർ നിങ്ങൾ ഓർത്തിരുന്നാൽ മതി. കാരണം ഇത് രണ്ടും ഐഡൻറ്റിറ്റിയാണ്. ഈ രണ്ട് ഇൻ്റഗ്രലും ഐഡൻറ്റിറ്റിയാണ്. ഒന്ന് R1 ടു ഇൻഫിനിറ്റി ഇൻ്റഗ്രലും ഒന്ന് 0 ടു R1 ഇൻ്റഗ്രലും. അപ്പോൾ നിങ്ങൾ സബ്സ്റ്റിറ്റ്യൂട്ടിങ് 10 അന്ന് 10 ഒന്ന് ഓർത്തിരിക്കണം. കാരണം 10 നമുക്കിവിടെ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താണ് ഫൈനൽ ആൻസർ വരുന്നത്. അപ്പോൾ ഈ I2ൻ്റെ വാല്യൂ എന്ന് പറയുന്നത് ഇറ്റ് വിൽ ബി പൈ എ ക്യൂബ് ബൈ 8r1 ഇൻറ്റു 1 മൈനസ് 1 പ്ലസ് 2r1 ബൈ എ ഇൻറ്റു ഇ റൈസ് ടു മൈനസ് 4r1 ബൈ എ ആണ്. സോ I2 വിൽ ബി a part of the integral of a part in the VE term. ഫിഫ്ത്ത് ഇക്വേഷൻ നോക്കിയാൽ VE എക്സ്പെക്റ്റേഷൻ്റെ ഒരു പാർട്ടാണ് ഈ ഇൻ്റഗ്രൽ I2 എന്ന് പറയുന്നത് അല്ലേ. ബാക്കി ഒരു കോൺസ്റ്റൻറ്റ് അവിടെയുണ്ട്, E²/4πε0 ഇൻറ്റു 8/4πa³ ഹോൾ സ്ക്വയർ. അതുമായിട്ട് ഈ ടേം മൾട്ടിപ്ലൈ ചെയ്യണം. ഇത് മൾട്ടിപ്ലൈ ചെയ്യുമ്പം ആൻസർ നമുക്ക് ആ ആൻസർ ഓർത്തിരിക്കണം. ഇറ്റ് ഈസ് 5a²/128. ഓർത്തിരിക്കാൻ എളുപ്പമാണല്ലോ, 5a²/128. ഇനി ഇതിൽ നിന്ന് a²/4πε0 പുറത്തെടുക്കുകയാണെങ്കിൽ ദാറ്റ് വിൽ ബി E1 അല്ലേ. a²/4πε0 എന്ന് പറയുന്നത് ഇറ്റ് ഈസ് ദാറ്റ് ഈസ് 5/4a ഇൻറ്റു a²/4πε0 വിച്ച് ഈസ് മൈനസ് 5/2 ഇൻറ്റു E1. E1 എന്താണ്? E1 നമ്മൾ ഓൾറെഡി പറഞ്ഞായിരുന്നല്ലോ, ഈ 8E1 ആണ് 109 ഇലക്ട്രോൺ വോൾട്ട് അല്ലേ. അപ്പോൾ ഈ E1 എന്ന് പറയുന്നത് ഹൈഡ്രജൻ്റെ എനർജിയാണ്. ഹൈഡ്രജൻ്റെ -13.6 EV ആണ് E1 എന്ന് പറയുന്നത്. ആ E1നോട് അതിനോട് മൾട്ടിപ്ലൈ ചെയ്യുന്ന, അതിനോട് -5/2 മൾട്ടിപ്ലൈ ചെയ്യുന്നതിന് തുല്യമാണ് ഈ ഇക്വേഷൻ. ഓക്കെ, 5/4a ഇൻറ്റു a²/4πε0 വിച്ച് ഈസ് -5/2. അതായത് a² എയും ക്യാൻസലായി പോയി. അപ്പോൾ പിന്നെ 5/2 ആണ് അവിടെ കേട്ടോ, 5/4a അല്ല. ഓക്കെ, 5/2 ആണ് വരിക അല്ലേ. അപ്പം -5/2 ഇൻറ്റു E1 ആണ് ആൻസർ വരിക, വിച്ച് ഈസ് -5/2 ഇൻറ്റു 13.6 ഇലക്ട്രോൺ വോൾട്ട് വിച്ച് ഈസ് 34 ഇലക്ട്രോൺ വോൾട്ട്. ഇനി നമുക്ക് ഈ 34 ഇലക്ട്രോൺ വോൾട്ട് വിയുടെ കിട്ടിയപ്പോൾ നമ്മൾ ഓൾറെഡി -8E1 എന്ന് പറയുന്നത് -109 ഇലക്ട്രോൺ വോൾട്ടാണ്. അതുമായിട്ട് ആഡ് ചെയ്യണം. സോ 34 electron volt plus 109 is 75, which is very close to the experimental value. So 79 electron volt was the experimental accurately determined value. ഇതുമായിട്ട് കുറേ ക്ലോസ് ആയി നമ്മൾ വേരിയേഷൻ പ്രിൻസിപ്പിൾ വഴി തിയററ്റിക്കലി കണ്ടപ്പോൾ. ഓക്കെ, സോ വിയുടെ ലാസ്റ്റ് ടേം, വിയുടെ എക്സ്പെക്റ്റേഷൻ്റെ ലാസ്റ്റ് ടേം വരുന്നത് ആ ഇൻ്റഗ്രേഷൻ്റെ പാർട്ടിൽ ഐഡൻറ്റിറ്റി വരുമ്പം കിട്ടുന്ന ടേംസാണ് ഈ എഴുതിയിരിക്കുന്നത്. ഇത് മാത്രം നിങ്ങളൊന്ന് കാണാതെ പഠിച്ചു വെക്കണം. അല്ലെങ്കിൽ ഈ ഐഡൻറ്റിറ്റിയുടെ എക്സ്പാൻഷൻ നിങ്ങൾക്ക് അറിയാമെന്നുണ്ടെങ്കിൽ അത് ചെയ്ത് നോക്കാം. അപ്പം ഇൻ്റഗ്രൽ ഓഫ് 0 to x or 0 to a e raised to ax into x, അങ്ങനെ ax into x² dx, ആ ഒരു ഫോം, ആ ഐഡൻറ്റിറ്റി നോക്കുക. അതുപോലെ ഇൻ്റഗ്രൽ another constant b to infinity e raised to ax into x dx, അതിൻ്റെ നോക്കുക. അപ്പോൾ നിങ്ങൾക്ക് അതിൻ്റെ ഐഡൻറ്റിറ്റിക്ക് എക്സ്പാൻഷൻ കിട്ടിക്കഴിഞ്ഞാൽ നിങ്ങൾക്ക് ഇങ്ങനെ ഒരു ടേം കിട്ടും. ആ ഐഡൻറ്റിറ്റി എക്സ്പാൻഷൻ്റെ വാല്യൂസാണ് ഈ ബ്രാക്കറ്റിനുള്ളിൽ എഴുതിയേക്കുന്നത് കേട്ടോ. ബ്രാക്കറ്റിനുള്ളിലും ബ്രാക്കറ്റിന് പുറത്ത് ടേംസ് കോൺസ്റ്റൻറ്റും പുറത്തെടുത്തിട്ട് എഴുതിയേക്കുന്നത്. So if you can by heart this value, equation 10, then it will be much easier. Only this equation you need to remember, and then substituting 10 in 5 and simplifying, you will get this 5a²/128. That also you have to by heart, 5a²/128. Okay, so you will get 34 electron volt, and then H expectation value, it will be -109 electron volt plus 34 electron volt, which is equal to -75 electron volt. So this is the helium atom system with the variational principle.